Today we're learning about determinants. Welcome to Essential Matrix Skills for Math 1010. We'll look at what determinants are, how to calculate them, and some tricks and rules about them. So what is a determinant? It's a single number we calculate from a square matrix of any size. And what does it show? It shows the sign and the size. The sign or the flip tells us if the orientation is preserved. A positive means it stays the same and a negative one it flips, kind of like turning a piece of paper over to the back. The size or the scale tells us how much the matrix shrinks or stretches the space. Does it make it bigger or smaller, or maybe even squish it completely flat? Keep in mind, here we mean the absolute value, so the magnitude disregarding the sign. You'll also notice that we use the same notation, those vertical bars, to describe both the absolute value and the determinant itself. Now we know what it means, how do we calculate the determinant? For a 2x2 matrix, it's easy. First, we take the down diagonal going left to right and subtract the up diagonal going right to left. That is, down minus up minus for a 2x2. Let's look at an example. Looking at the formula and remembering our rule, down diagonal minus up diagonal, we can begin to calculate. 1 times 4, that's 4, minus 2 times 3, that's 6. When we subtract, we get 4 minus 6, which equals negative 2. So the determinant of this matrix is minus 2. What about when it's a 3 times 3 matrix? Let's go through the formula. The pattern is similar, we just have to calculate 3 2x2 determinants. First, we take A and multiply it by E times I minus F times H. Then we do the same thing, but we subtract B times D times I minus F times G. And finally, we add C times D times H minus E times G. Watch out for the pattern plus minus plus across the top row. Make sure not to forget about it or mix them up. Again, let's look at an example for this. So following the same structure as our earlier slide, let's put in the numbers. We start with plus 2 multiplied by the determinant, that's 4 times 3 minus 0 times 8. Then minus 1 multiplied by its smaller determinant, that's 0 times 3 minus 0 times 2. And finally, plus 5 multiplied by the last one, 0 times 8 minus 4 times 2. Now we just work out those multiplications and put it all together to get the determinant of negative 16. Again, just watching out for that plus minus plus pattern. Calculating a 3x3 determinant can be sort of time consuming, but there is a shortcut. In this example, if we used a 3x3 formula, we'd eventually get the determinant of 120, but there's a much quicker way. If a matrix is triangular, meaning everything above or below the diagonal is 0, we can skip all that expansion. For our example, there are zeros in the upper triangle, so it's a lower triangular matrix. If it's triangular, we can use the product of the diagonal. So we're going to multiply the numbers along the diagonal to get the determinant. In this case, 4 times 5 times 6 equals 120, which is much simpler than working out the full 3x3 formula. The shortcut works because in the 3x3 formula, so many of the terms cancel out that the only thing left is the product of those diagonal numbers. Determinants are just numbers, which means we can set up an equation and solve it, just like any other number. Looking at this example, we need to solve for x, and we'll use our 2x2 determinant formula. So following our formula, down diagonal minus up diagonal, we get x times 5 minus 3 times 4. Add 12 to both sides to get 5x equals 60, then divide by 5 to get x equals 12. Okay, so we know how to find a determinant and even use it in an equation. Let's look at what happens when we change or multiply the rows in the matrix. We're going to look at the properties of determinants, specifically the row operation rules. Remember, the vertical bars here don't mean absolute value, they mean the determinant of some square matrix A. Rule 1. If you swap two rows, the sign changes. Positive becomes negative or negative becomes positive. Rule 2. If you multiply a row by some constant k, the determinant also gets multiplied by k. Rule 3. If you add a multiple of one row to another, the determinant stays the same. Let's go through each rule with a bit more depth. Rule 1. If you swap two rows, the determinant sign changes. So for a general 2x2 matrix A, with row 1 as A and B, and row 2 as C and D, and the operation being swapping rows 1 and row 2, the new matrix becomes CD on top and AB on the bottom. Let's look at an example using the same operation where we swap row 1 and 2. Now if we work out the determinant, we can see the original one is 5 and the one with the row swap is minus 5, proving that if we swap two rows, then the effect on the determinant is that it becomes negative. Moving on to rule 2, where if you multiply a row by some constant k, the determinant is also multiplied by k. So for a general 2x2 matrix A with row 1 as AB and row 2 as CD, and the operation being multiplying row 2 by k, The new matrix becomes AB on top and KC and KD on the bottom, where the effect on the determinant is multiplied by K. Looking at an example where K equals 2 and A is the same example as before, the bottom now becomes 2 times 3 and 2 times 4, so 6 and 8. Then we calculate the determinant of each. The original one is 5, and the one with the K equals 2 is 10, or 2 times 5. This proves that if we multiply one row by K, then the effect on the determinant is that it is also multiplied by K. If you add a multiple of one row to another, the determinant stays the same. For a general 2 by 2 matrix with row operation of R2 becoming R2 plus some constant K times R1, the bottom row becomes C plus KA and D plus KB. The effect on the determinant is that it remains unchanged. Let's do an example where K equals 1 to make things more simple. The operation is row 2 becoming itself plus row 1, so the bottom row becomes 3 plus 2 and 4 plus 1, which is just 5 and 5. Then we can calculate the determinant of each, and after that we find that they end up being the same, 5 and 5. This proves that if we add a multiple of one row to another, the determinant stays the same. So what did we learn? We learnt the 2 by 2 matrix determinant formula. Remember, that's the down diagonal times together minus the up diagonal times together. We also learnt the formula for a 3 by 3 matrix determinant. We learnt that if we have an upper or lower triangular matrix, that the determinant is the product of the diagonal numbers. And we learnt the 3-row operation rules. If we swap 2 rows, the sign of the determinant flips. If we multiply a row by K, the determinant is also multiplied by K. And if we add a multiple of one row to another, the determinant doesn't change. Thanks for watching, and we hope to see you in our next video.